Hello, this is another video from Engineering Dude, and here we're going to be solving this problem using the resultant method. A good rule of thumb is to always use the resultant method when there are two or less forces at play. If there were three or more forces at play, then you might want to use the component method. The reason why I stress this is that your statics teacher will probably expect you to know both of them and might put them on an exam or test stating that you can only use one or the other. To start solving this problem, we want to start with a free body diagram. And so we draw the origin, we draw force 1, this is 50 newtons, and the angle is 25 degrees. Then we draw our origin axis, then we draw our force 2, and this is angle alpha, this is an unknown, and it's also magnitude of P, so the problem statement tells us that P is 35 newtons. Once we have a free body diagram, we can start with our analysis. These are all the exact same laws, so it's easy to get confused on it, but the parallelogram law, the triangle law, and the head to tail method, they're pretty much all the exact same thing. And I'm just going to say that I'm going to use the head to tail method just because it's easier to remember. But pretty much to analyze two forces like this, and to find the resultant, you just want to draw force 1. Doesn't matter which force is force 1, you could draw this one or this one. And then you just draw force 2 on the head of the first arrow and then the tail of force 2. And the reason why we know that our resultant is supposed to look like this, is supposed to be completely horizontal, is because it also tells us in the problem statement that if the required angle, or find the required angle of alpha if the resultant of the two forces applied to the support is to be horizontal. So the resultant, this right here, is supposed to be completely horizontal. And so this is force 1, which we classified as 50 newtons, and it's at angle 25. And this is force 2, which this is 35 newtons. And we don't know what this angle is, so we're going to call this angle theta. And this right here is angle alpha. So now that we have our free body diagram, we have to remember that when we're using the resultant method, we have to remember two very important trigonometry laws. The law of cosine, which states that a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of the angle opposite to a. And we also have to remember the law of sine, which states that a over sine of the angle of a is equal to b over sine of the angle opposite of b equals c over sine over the angle opposite of c. So these are two very important trig laws that you are expected to remember in almost all statics classes. And so we're going to apply these laws to our little diagram here, our free body diagram, but we're just going to draw it bigger so we have a better understanding of what's going on here. So this is angle alpha, this is the unknown theta, and this is 25 degrees. We have 50 newtons right here, 35 newtons right here. And then this is some random resultant magnitude or whatever. If we apply the law of cosine, we can label, because we know that a squared right here, we have to know the opposite angle of a. So the only way that we can know this is that if 25 is that opposite angle. So what a squared must be is a squared must be 35, because that's opposite of the angle of 25. So if we do 35 squared equals, and B and C are interchangeable, but just remember that B and C have to be, one of them has to be unknown. So we'll just say B is 50 newtons. So 50 newtons plus C squared minus 2 times B is 50 times C, because that's unknown, times cosine, and then the angle opposite of the side of A, so 35, and it would be actually 25 degrees. And now we can just solve for this. Cosine of 25 is 0.91. 50 squared is 2,500 plus C squared minus 100 times C. And then 35 is 1,225. And then we can bring this to this side and we can simplify, and we'll end up with C squared minus 91C plus 1,275. And now we can see that this is just a quadratic equation. And to solve quadratic equations, we use our quadratic formula, which is minus b plus or minus square root of b squared minus 4 times a times c all over 2a, where a is 1, b is 91, negative 91, and c is 1,275. And you're going to end up with two answers, and a good way to know what answer is the right one is to say, okay, so this is the longest line, because this is the two forces added together to the left. So it's supposed to be larger than 50 and larger than 35. So you're going to come up with one that's like 13, and the other one is going to be 73.7. And this is the correct one because it's larger than 50. And so when you put this all in, you end up with 73.7 newtons. And so this is the resultant. And now, a good rule of thumb is that once you've already applied one law, and you still have an unknown, so we don't know what angle this is at, we don't know what angle alpha is, all we know is the resultant, we just apply the other law, so law of sine. And law of sine is A over sine of A is equal to B over sine of the angle of B. And we can actually just kind of make this a little bit more easier on us by flipping both sides. And you can do this anytime you want, just as long as you flip them both. So if this was C, you can just do sine of C or whatever, and you can just flip it too, as long as you flip both sides. And the reason why this makes it easier is that we don't have to invert it later on. But sine of A, we know that sine of A is 25, so sine of 25 over A, which is 35 newtons. And then sine of B, which is the alpha, we don't know that. So we're going to leave it as sine of, we're going to change it to alpha actually. Over, and then B is 50 newtons. So we just move this newtons over here, and we multiply it together. And at the very end, you should come up with this answer once you solve for, once you take the sine inverse of this side again, and you just end up with alpha. You should end up with 37.14. And so our final answer would be 73.7 newtons at 37.14 degrees. And you draw this little symbol, and everything should be okay. Alright, that's the end of the problem. Thank you for watching. Bye.